how could you possibly know what latest additional material I've added to my ebook unless I talked about it, because it's now over 170 pages long, and you know, you so the only way to find out is if I do a video. So I made this edition a few days ago. I've done a few others since then, but this one I want to draw your attention to. It has to do with point number 4 on this chapter called Solving Drive Shaft Rotation Challenges. So let me just read you the top paragraph. When you've got a moderate frequency over unity circuit driving a motor shaft, the challenge will be to rotate the drive shaft. For the drive shaft will want to spin at a much slower rate of maybe 30 hertz, 1800 RPM or less, while the motor shaft is being alternately shook or vibrated at 50,000 hertz or higher, equivalent to 300,000 RPM, if this were operating under a positive power factor, which it isn't. What do you do? So I cover a few options, I think 1 through 3, which will not work. And then everything after that probably will, but starting with option number 5, it gets a little complicated. 5 and 6 and their subparts are, 5 has to do with a hydraulic transmission, and 6 has to do with, let's see, yes, electrically converting AC to DC by using various techniques. One is capacitive saturation and the other is inductive saturation, and with capacitive there are 2 subtypes. In any case, it's all very complicated. So, what I came up with was, you see, I worry too much, basically. I worry, is this going to work? Is it buildable? Why has nobody told me they haven't succeeded? Well, maybe the few who have attempted to did not, and they don't want to hurt my feelings, because I've got such a good thing going here. It gives me a positive outlook on life, and I learn all these other things. So, why break my reverie? Well, that's nice. But so that's why I'm making this video, in case you're trying to be kind with me. I don't operate very well with kindness. It's nice, but I grew up with pressure because I'm a bit of a black sheep, if you haven't figured that out by now. In my family, they look down their noses at me, so I actually operate better under pressure. And that's why I periodically go to the conservative camps to try to get some feedback, because it actually expands my awareness, which otherwise might happen, but at a snail's pace. They accelerate my progress. Anyway, the point of this video is to highlight point number 4 here, create a beat frequency. It was an idea I came up with several months ago. I've gone through a lot of different editions of this ebook, and I dropped it. I used to talk about it because I really doubted it would work, it would help. Because when I would do the simulations, I found that the power level of the beat frequency must be pretty small. So in fact, I never saw evidence of a beat frequency. And I shouldn't be surprised, because it's a mathematical fiction. So why should I see the oscilloscope tracings depict it directly? But I would see evidence. In one of the 2 parent frequencies, there would be a diminishment of frequency from what was inputted. So I had 2 input sine wave generators. One, and the difference between them was the frequency I was trying to create to rotate the motor shaft at a more decent rate. Now I use my target is 80 hertz. It's not 60, because if we read Thomas Comerford Martin's book on the subject, having to do with, let's see if I can do this safely without showing off my X-rated desktop. Let's see. We need a new window here. Oh, I'm not connected to the internet. This is not going to help me. So let's try a different approach. Let's see, I have it on my computer somewhere. See, I did a transcription of the last chapter of Thomas Comerford Martin's book on the inventions and researches of Nikola Tesla, because he gave you a demonstration in 1893, I believe, and that contributed to his last chapter. Thomas was an electrical engineer, and all the other electrical engineers who showed up at the demonstration found out about Tesla's special generator. This is what William Line talks about in chapter 8, I believe. I keep thinking it's 18, but I think it's chapter 8 of his book, Pentagon Aliens. And then he had the lab fire 2 years later, and then Carl Linde of Germany, Linde, pretty much stole. It became obvious that somebody stole it on his behalf, or he stole it himself, the liquefaction of air, and then he went and patented it. But they never patented the special generator of Tesla, probably because they didn't understand it or whatever. I don't know. But of course, to hide the theft, somebody set set fire to Nikola Tesla's lab, and that hid the theft. So I went and transcribed the last chapter, and I had to repost it on various places. I think I posted it. Yeah, I posted it on Google Play Books, and I have a shortcut to it, I hope. Let's see if I made one. Oh, I did not make one, I don't think. Yeah, not yet. Anyway, I linked to it in my book, in the text. So that's the important thing. So you'll see it if you see that chapter. Let's go see the chapter. Let's see, where are we? Yeah, right here, 80 hertz. So underneath this link is the link to, actually that's at archive.org, somebody else's text, and I go exactly to the page where he says his apparatus was running at 80 cycles per second. But then I did the math. See, there's this story, different versions of the Pierce Arrow demonstration of 1931 in Buffalo, New York. And what I did was I made a presumption, a speculative presumption, that the aerial on the backside was bringing in one frequency, and the two switches, the aluminum rods sticking out of his project box, sitting on the seat, the passenger seat to his driver's right, where he had his project box, that served as two switches, but it also doubled as either one or two antenna. And I assumed them to be an inch in height, and the aerial, although not exactly 2 meters, I just rounded it off to 2 meters, and assuming a quarter wavelength resonance for each of those objects, I determined that the 2 meter aerial was resonant with a wavelength in the frequency range of 37.5 megahertz. And then the little 1-inch switches were resonant with nearly 3 gigahertz. And if you divide 3 gigahertz by 37.5 megahertz, you come up with just a little bit under 80 hertz, 78 3/4 to be precise. So I took this to be fairly, strong enough evidence that my presumption might be correct, that he was creating a beat frequency. But see, when I came up with this insight or inspired insight a few months ago, it didn't take long for me to dismiss it, because when I looked for evidence, as I said before, I saw a diminishment of frequency in one of the parent waves. I think it was the shorter, or I should say not the shorter, the longer of the two, the one whose pitch was less, the 37.5 megahertz frequency was reduced. It would tend to go down to 33, and I thought that was a little strange that it would go down so little. Surely it should, that would have the greater energy of the two, not the higher frequency, but the lesser. And so it kind of made sense that the energy was stolen from that or borrowed, to create the so-called mathematical fiction that you can't see on the oscilloscope. You can only infer it by looking at the amplitude of the two parent waves, or the frequency for that matter, by how much do they diminish in either frequency or amplitude or both. But it didn't look like enough. And of course, I never did the math. I wouldn't know what kind of math to do to see what the equivalent would be at a lower frequency. It might have been enough, quite frankly. But assuming that it's not enough, and assuming, because that's the assumption I made a few months ago when I dropped this idea, and I had to reinsert it when I realized, you know what, maybe I shouldn't be so worried, because all the power is in the separation of current from voltage by 180 degrees. Let's see if I put a... So there's the circuit. Let's see. No, I don't have it here. Okay, I'll have to bring it up. There's another place. Where is it? Is it here? I have it. I have so many schematics and images in here. Nope, it's not there. Alright, where are we? Situation, vulnerability, solution. Maybe it's here. Nope. I know it's here. I know it's here. Oh, no. No, it's not there. Come on. Is it here? No. It might be here. No. Oh. Where is it? There it is. Okay, so here you see the blue is the voltage and the red is the current. And so they're displaced by a full half AC cycle. Yeah, and that's where all the power is in the negative power factor area of the wave types. So I thought to myself, well, maybe it's not so bad after all. All we have to do is create a tipping of the overall condition to get the rotor of the motor to spin. And it may not be necessary to do one of the images you just saw. Well, it shows up again. Where is it? It may not be necessary to create a a full bridge rectification in order to supply energy to the starter coils, which are located on the rotor of all places rather than on the armature, to get it to spin. It may not be necessary to have this extra place, because if we do this extra circuit, things get complicated, because then we have to either pressurize this capacitor or depressurize everything else within a vacuum in order to get the equivalent series resistance of this capacitor up to 1 mega ohm, which, is a kind of ridiculous figure. It may not be necessary to do all of this. It may be possible that what was I saying? All that is necessary. Let's go back to where we were. Solving. All that may be necessary is to create a simple circuit, two circuits. This one is the higher of the two, so this has 1.35 megahertz, and I picked that arbitrarily. Well, not arbitrarily. It was the highest I could go before my simulator would crash on me and give me all kinds of error messages when I extended the time, the duration of the transient analysis beyond, a tiny amount. So I couldn't really get a good waveform. So I was limited to 1.35 megahertz with 3 volts in order to get a nice 30 micros, 300? Is that 300 or 30? Without my glasses. 300 microsecond duration to get these nice staccato arches or wedgie shaped, yeah, those things. So we take 1.35 megahertz, divide by 22.5 kilohertz to get a 60 cycle per second beat frequency. And that's what this other circuit will do, is create the right lower frequency of 22.5 kilohertz. Now let's go back. It looks like the same circuit, doesn't it? And so I had to do them separately in order to show you the results, but that's not the way we construct the darn thing. And these are is the output of another choice of 16,875 hertz in order to create an 80-to-1 difference, an 80 hertz and 80 cycles per second beat frequency. And the staccato wedges are just under 7 hertz, which is kind of slow. But they're pretty good, 530 volts peak to peak. Not as good, though, as the 60 hertz, because the 60 hertz is right up there at 1.2 kilovolts, and that was consistently what I've been doing when I have only a single sine wave generator, putting out 50 hertz or to 70, somewhere within that range. But what we do to put it together, if I can get it, here we go. Let's enlarge this. So what we do is we have two circuits. Now the starter coils we don't connect them to anything, because I've done simulations in the past where it's really not necessary to connect them to anything. We just leave them alone. So we're really only using the main motor coils, and then we attach a circuit to that. The main motor coil that is on the armature of a single-phase induction AC motor. Now we do take the wires off, and rather than do a bifilar, we do a quadrifilar, but we only unite them in pairs so that they're two sets of circular rings wound back upon that bobbin. Or, in the alternative, we have two bobbins on opposite sides of the armature, and one is bifilar and the other is bifilar, depending, I don't know. It could be one way or the other. And then we have the squirrel cage rotor on the inside. But so all of these four coils, the two sets of bifilar actually is the way to say it, are both on the same armature, along with the starter coils that are electrically isolated from everything here. And then we have a separate circuit for each pair of bifilar main motor coils. We have another spark gap and a separate diode bridge and capacitor that's going to get charged up and filled up. And then two separate sine wave generators, one, in this example, one at 50,000 hertz, 3 volts, and this one at 5 megahertz, 3 volts. So this is showing 100-to-1, 100 cycle per second beat frequency in this example. But you get the idea, I hope. So basically, where these two circuits join together are the mutual coupling, the 99.9 or whatever it happens to be, mutual coupling of these two sets of bifilar motor coils that are both sharing the same magnetic field on the same armature. And then the other coupling is the fact that they both share a 10% relationship, mutual coupling relationship with the squirrel cage rotor. And they also share a 99% coupling with the two starter coils. So there's a lot of magnetic connection between these two electrically isolated circuits, but they are electrically isolated. And so my hope is that it'll be in the magnetic field of the armature in that the beat frequency will appear. Because electrically, it might appear as a ghost in either one of these two circuits, but only as a consequence to the shared magnetism uniting the two sets of bifilar main motor coils, transferring, or converting, I should say, that magnetic beat frequency back into the electrical portions of these two circuits as a consequence, as a echo, shall we say, an electrical echo coming back into the circuit. It probably will happen, but the main strength or amplitude of the beat frequency will be in the magnetic field of the armature. And I figure that's good enough because ultimately we have to have it spin the rotor. And it doesn't even have to be powerful. It might be more powerful than I had imagined because I forgot that when you reduce the frequency, you're using a beat frequency which is vastly lower than these two very high, well, they're considered moderate frequencies, but it's 80 or even 100 cycles per second is 500 times less than this example. So obviously the energy is going to be higher in a very low, frequency, a low frequency beat frequency, and it might be enough, plenty of power to rotate the rotor. But what my hunch was recently is that maybe I don't have to worry because most of the power is available. It just has to be tipped. There has to be a slight imbalance. It doesn't have to be 100%. All the energy has to be positive power factor format. So we don't have to convert all that energy. We can have the negative power factor as a kind of latency waiting to be utilized, and all we have to do is tip it slightly. And the rest might be automatic, I'm assuming, so as to not to worry about it, because I really think it was unjustified for me to worry and leave it out, because it's the simplest solution on how to correct for the negative power factor to get this motor to run. It makes everything else look so darn complicated and gee, what's he smoking, or drinking for that matter. But it was really my worry, my habit of worry, that caused me to lose hope about this idea and instead turn to more complicated and arduous techniques that could prove impossible to implement, or else very difficult or just imaginary. So I'm always trying to make my simulation as realistic as possible. And I have to use my imagination, but I have to be free of doubt. So I'm pretty certain now it was a waste of time for me to doubt. Partly because all we have to do is slightly tip the balance of negative power factor into the direction of positive power factor, or it may be that because I failed to do the calculations, my speculation about how much power am I going to get when I subtract from a high frequency and it manifests in a much lower frequency, how much is going to manifest there? It could be plenty, more than enough to spin the rotor. So yeah, that would mean that this motor then, in that latter analysis, is wasting a lot of energy because we have all this negative power factor we're not using. But are we not using it? We're using it to excite the coils. We're using it to, what's the other word? Well, warm it up, in the common vernacular, so that, the mathematical fiction of the two parent reactive components, the capacitive reactance and the inductive reactance, they're useless, and they combine to form their daughter wave of a negative power factor, which is also useless because the wattage is zero, even though it's in the real domain and not in the imaginary or complex domain. It's still useless because the wattage is zero, and that's why everybody thinks it's a waste of time to bother using it. But we do need that energy anyway, and we're going to use it to charge up. That's the word I'm looking for, to charge the coils. And so that energy is going to recycle. Minus any losses, it's not going to be consumed necessarily, for the most part. But apparently it is being consumed, or else I wouldn't have seen a diminishment of the parent waves. They're both, well, I don't know about their amplitude, but their frequency was certainly evidence enough for me to presume that their amplitude was being subtracted as well. So that's what I had to say. I had to present this because, it's a problem taking me seriously. It's a real problem. It's a hard sell. And it's partly my fault for being a doubting Thomas, which is not a bad thing, you know. I'm trying to stay real on the one hand, yet I can overdo it and exclude things that have a potential for supporting, at least, you know, hypothetically or theoretically, supporting this circuit concept. And if I doubt too much, I exclude that, and then we get nowhere. You know, I'm trying to help this along, and I know my intuition has been, yes, this works. It's just a question of how do you go about interpreting the simulation, because the simulation doesn't tell you everything. And that's the other reason why I don't build this, is I know it's going to be more difficult. It's been difficult enough as it is, but I've said this so many times before, and it's worth repeating. The amount of workload I've had to go through is enough for one person alone. Let me tell you, it's a bitch. And I don't need the extra workload of building it, because all I've done is taken care of some of the main points. I haven't taken care of all the details. You know, like what composition of material do you use? What grade of steel or copper? You know, all those details. It's just adds to the nightmare of building anything anyway. And especially building something new that nobody's ever built before, successfully at any rate. So my simulations are not unrealistic. You know, I use microcap for a reason, but they are overly simplified. I give that much caveat. They are oversimplifications. They are simplifications, whether or not they're oversimplifications. They're simplifications of the real world. And so there are a lot of details missing that I don't know about and I can't coach you on. But I try to think about as many as I can to help bridge the gulf that exists between the simulation and the reality of actually going ahead and performing a successful build. So that it's more likely that you'll want to try and more likely to succeed. But I don't have the technical savvy to build anything. I don't have equipment or even the knowledge of how to use it. I could learn, but let me tell you, this workload alone of just doing the simulations and thinking through the consequences of them and then writing about it and distributing and promoting it, that's a full-time job, let me tell you. It is a full-time job, and for which I do not earn a whole lot of bucks. I did in the beginning, and now I don't get anything out of this, so it's no wonder I have to spread it around for free, because I'm not going to make money off of this from this point on. It doesn't look that way, at least at the moment. But I am trying to reduce the mystery behind it as much as I can so that it's less intimidating. That's the word I'm looking for. I don't want it to be intimidating for lack of realism. For whatever reason, you might find an excuse to say, oh, it just doesn't seem realistic. Well, it's true. You never heard your friends talk about it, so you have nothing to judge this by, to compare it with. The judgment, though, we have to go back to Joseph Newman. And for that, I will finish up this video. One of the early chapters in this saga of writing this book is I wrote this synopsis, how many points is it? 38? No. Yeah, 38-point summary of what makes my device different from Joseph Newman, but an offshoot, because I have already simulated, prior to this work, I simulated his device. And this is an example of a 300 RPM version, which, assuming, you could get the rotor to spin that fast, it's more likely to spin a lot slower than that. But I did the simulation as I chose 300 RPM, what can I say? And then I did, for comparison, a 6 million RPM. And the difference was night and day. The difference was the difference between it being not over unity at the slower rate of rotation versus being over unity with enough, just a scant amount of milliamps of current to recharge the batteries. And so if I look for it here with squinting my eyes, half an amp is charging the batteries, negative half an amp. And the voltage on the massive coil is, I believe it's 566, no, that's the watts. Where's the volts? Oh, no, where's the volts? Coils, coils, coils. Rotor, out. Well, I know it's here somewhere. I did all the measurements. Rotor. It's not the rotor. I think it's the coil. L1, L2. Oh, wait. Which one? Oh, okay. L1. So L1 amps, volts. Here we go. Oh, wow. 1,000 volts on the coil, on the massive coil. Now, there's a lot of impedance. I believe, wow, 600 kiloohms. Oh, that's at the battery. Okay. Oh, I see. No. I'm sorry, excuse me. No, the massive coil has 1,000 ohms of impedance. Yeah, that's it. The rotor has a mere 3 picoohms of impedance, and the battery pack has impedance of 620 kiloohms. But where's the voltage on the... God, I don't seem to have it here. I just have wattage. Oh well, I guess I never wrote out the volts. I wrote the amps. Yeah, we got about 780 milliamps on the massive coil and 100 megaamps on the, or not on, but in the magnetic field surrounding the canister of helium that's spinning, you know, surrounded with an open coil. And that is in the space surrounding that, so because it wouldn't show up in the open coil, that would be just a voltage difference. I don't seem to have a voltage measurement for either of those two coils. Maybe, oh, I know why, because it was equivalent to my out. Okay, I just have it labeled. Okay, I'm a little confused. So, no, I just have wattage. Where's the volts? Yoo-hoo, volts. In, out, rotor. I didn't put down volts. How bizarre. Rotor voltage, out. Kilovolts, out. Oh, there it is. No, yeah, 1,000 volts. Oh, okay. Yeah, Dr. Hastings had measured 600 volts, so it's kind of in the vicinity. So this is the over unity version, and of course you can't get a rotor to spin 6 million times per minute, but you can get helium to become excited in the high frequency range and put out an electromagnetic frequency that's probably comparable to this, and then that sine wave, or whatever wave shape it is, will blend with the square waves, the slower square waves coming from the commutator of Newman's device, and create a complex waveform. But, excuse me, the power, there'll be just enough negative current to recharge the battery pack. So what I did was, I realized that, well, only after I sat on this for a year, because I was really numb, I was confused. I couldn't believe that Newman had lied to us, but he did. And, you know, we don't have to call it lying. Just say it's proprietary information that he has every right to keep a secret because it's proprietary. So I doubt he told anybody. I don't even know if he told Jeffrey Miller, but he certainly probably did not tell the patent office, or if he did, that might be why they tried to screw him so badly. I carry a whole I spent a whole chapter on that in this ebook, because there is documentation how they screwed him. I looked it up. When Newman claimed it, I looked it up and verified to my satisfaction. Yeah, it doesn't take much intelligence to figure that out. Anyway, I don't want to dwell on that. But I sat on this because I really was confused. And even after Byron Brubaker told me what the secret was, because he gave it to Newman, it's still, I couldn't deal with it emotionally. It was too much. So I had to sit on this a year. And then when I turned my attention back to it, I decided, you know what, I know what this is suggesting. So why don't I just go ahead and start working on it again? It was suggesting, first of all, that I had a complicated design. I have all these grounds, and they're all common grounds, and it makes things complicated. So I simplified the circuit, by uniting all the common grounds, and then I realized the circuit has a short. And it's not there obvious if you exclude the input or the contribution that the rotating mass in the center of the coil, whatever that happens to be, if you believe it to be the older version that Newman built his device based on a rotating bar magnet, or the newer version that he never told anybody, being this spinning can or the spinning glass canister of helium surrounded by an open coil. Regardless, if you don't include that rotating mass and the magnetic field surrounding it, you have an incomplete simulation. You have to include it. It's just a question of whether or not it's going to be over unity, depending on which version you take to be reality. The older version that Newman tells everybody to build versus the one that he actually ended up building that we know about, but he didn't describe its inner workings. He kept it a proprietary secret to himself. The helium, the use of helium creating a high frequency electromagnetic output. So regardless, you have to include that spinning mass to be a complete simulation. And that means a waveform I took to be sine wave. It may not be, but it's going to create a complex waveform when it blends with the square waves coming from the commutator. So, you have to think about all these things when you do a simulation, or else your simulation's not going to be realistic. So I try to be realistic or accurate. I try to be accurate as much as possible so that it is also, seemingly realistic to some degree. But when I reorganized it and got rid of all the extra common ground connections, it was evident to me right away that there's a short. And that's when I came up and discovered this concept of a shorted motor. And Byron Brubaker, again, when we had another conversation, shared with me that that's not uncommon. It's been around 100 years. So, people have been toying with shorting their motor or shorting their transformer or shorting their generator to see what would happen. And usually it would fry itself. And even Jim Murray admits that it's common knowledge by anybody who builds motors, if they're lightly loaded. So I don't know how this thing will work when heavily loaded. That's the one thing I have not simulated. At least I'm confident that it'll work, but I don't know that. So I have, it's an open question thing for me. Will it work or not? In any case, this is how I based my design off of. And you can see the waveforms here are strictly simplistic, but that's because it's not over unity. We're getting a cost. It's putting out 20 kilovolts on the peak here, and we only get back to the battery pack negative 2 kilovolts. So we're losing 10 times more than we're gaining. And the amperage on the battery pack, 16 amps versus negative 2 amps. So there's no way this thing can feed the battery pack any energy and be over unity when we take the build exactly, the instructions exactly the way he tells everybody to do it. There's no way it's going to happen. You do the simulation, you find out in advance it's not going to be over unity. And it has nothing to do with the size of the device. It's not going to help you. You can make it as big as you like, and it's still not going to be over unity according to the specifications he outlines in his book and tells everybody. It's just not going to happen. So you can go looking for the Man of La Mancha fictitious windmill if you like, but I'm saying, dream on, because that's all you're going to do is keep searching and never find the holy grail of the Newman over unity. It's just not going to happen. You've got to do something different than what he has told us. Maybe he told Jeffrey Miller, and maybe now Jeffrey Miller is sharing that with people. I don't know. But it's got to be something that whatever Joseph Newman publicly disclosed, because it's not the whole story. And that's totally common for an inventor to not tell the whole story. So I should never say lie, because it's what inventors do all the time. They keep a little secret to themselves, or a lot of secret. Very rarely do they put everything out there. I've seen some patents that they tell you everything, but it's usually like a toy or something in which they don't expect anybody to get rich off of, creating free energy, so they spill all the beans. Okay, and I know I'm not going to get rich off of this, so I try to share as much as possible, because the competition will be fierce to try to, make a bundle off of this, like, really, reality check there, right there. You'll be lucky if you get away with it just building it in your shop and getting it to work. That'll be fantastic in itself. That'll be pretty good. And I don't doubt maybe someday I'll build it, but only when the social environment is less antagonistic, far less than what it is currently, because I don't need the extra stress. Right now, I got my hands full, but maybe down the road, a few years, decades, maybe then I'll pick up and build it, or maybe if I should become wealthily endowed with lots of money. But at the moment, I'm pretty poor, and I just have my hands full just doing what I do. So that's enough for me. But I want to share this with you so you don't get any silly ideas that, oh, he's talking through his noggin, but we don't want to hurt his feelings, so we don't want to tell him what we really think. Because we're his friends, right? Hey, you can. My mother was always blunt. She never, if she would keep secrets to herself, but if she had she just told you. She didn't hide it. So I grew up with that, the blunt truth. So you don't have to baby me. You don't have to. In case you've been doing that, you don't have to. You're not going to hurt my feelings one bit. Okay? All right. So we've cleared that up, I hope. Okay.